Now, this question says the length and breadth of a rectangle increase by 20% and 30% respectively. Find the net percentage change in area. So, the length increases by 20%, breadth increases by 30%. You have to find the net percentage change in area. Let's see. We know that this is the shape of rectangle, right? I hope it looks like a rectangle. Now, suppose this is the length, this is the breadth. What is the formula of area of a rectangle? We all know area of a rectangle is length into breadth. Okay. Here in this case, we are saying the length is increased by some percentage and breadth is also increased by some percentage. We'll get to that geometrical aspect of it. First, numerical process. Let us assume that the original situation, length is equal to 100, breadth is also equal to 100. Doesn't matter because square is also a rectangle only. So you can assume any value. So original area will be equal to, let's say it is 100 meter, 100 meter. So it is 100 into 100 meter square. That is 10,000 meters square. This is the original situation. Now in the new situation, what will happen? Length will increase by 20%. So whatever was the original length, it has to increase by 20%. So it becomes 120 meter. Whatever is the original breadth, it increases by 30%. So 100 increases by 30%, the new breadth will become 130 meters. So the area new area will be equal to new length, that is 120 meter, into new breadth, that is 130 meter, which is equal to 120 to 130 is 15,600 meters square. So we have to find the percentage change from this value, original area, to the new area. This is our initial value, this is our final value. So the percentage change in area will be equal to 15,600 minus original value. This is final minus initial upon initial into 100. Into 100. So this gives us 5,600 divided by 10,000 into 100. 0, 0, 0, 0, 0, 0, 0, 0. So answer is 56%. So this is one way of doing this question. This is the proper method of doing this question. Okay. Now let's see if we can apply the successive change method in this. Right. Look at the geometry cast. So this is standard procedure. There is nothing. This is a pure conventional method. Everybody can think about it. That assume the original value separately, find the new value separately, and then calculate everything that is required to be done. Now let's look at whether we can apply the successive change method in this case or not. Now in a rectangle, is it possible that you increase the length and increase the breadth simultaneously? Can you change the length and breadth simultaneously? No, it won't. Why? It won't be possible because, see, the rectangle should not lose its rectangleness, right? It should not lose the property of being rectangle, right? At any point in time. So what we have to do is, any change has to happen only one by one. Okay, so the change in length has to happen once. Let's see how. How would you change length? Hold this breadth and stretch, shift, right? So if you draw it, if you shift it here, you can see that the length has increased, right? And this would be gone. I'll just put it like this. So the length has increased. You see, this is L. This is the incremental L, right? And what is the incremental L? It is 20% increment in length. Do you realize that the area also has increased just by changing length? You know, for example, if I have, let's look at this rectangle. This is the length. This is the width. If I simply double the width, what will happen to the area of rectangle? Look at this carefully. If to double the width, I just open it. So as you can see, the width has just doubled. Can you see that the area has also doubled? So any change in any of the dimensions will have its effect on its area. Let's look at it once more. If I increase the width by 50%, what will happen? Look at this. This is the width. 50% will be this much. If I just increase the width, you can see that the area also. Now this strip is exactly half of the area of this rectangle. That means any change in the length or in the breadth will have the same effect on the area also. What does it mean? If the length is increased by 50%, area will also increase by 50%. If length is doubled, area will be doubled. If length is half, let's say for example, if this is the length and if it is half, you can see that the area is also half. So whatever percentage change happens, look at this carefully. This was the original length. If I reduce the length by 50%, that means I make it half. The area also becomes half. Then I reduce the width by 50%. Area also becomes one half. But you see, if I do both changes, then what will happen? Reduce the length by 50%, reduce the width by 50%. So the net area becomes 1/4 of the original area, only this particular segment, right? And this particular segment, remaining portion, is the 1/4 of the original area. Okay, so what you need to memorize is, whether you understood this or not, no problem. Just memorize that whatever percentage change happens in length, the same percentage change will happen in area. Whatever percentage change happens in breadth, the same percentage change will happen in area, right? But one by one. Oh, so that means we can apply our original method, one more method that we had. We can assume original area to be 100. Then, because length has increased by 20%, so I'll increase area by 20%. Just now we said, whatever is the percentage change in length or breadth, the same percentage change will be applied in area. The only condition is one after the other. So area will increase by 20%. I'll write due to change in length. So due to change in length, area will change by 20%. Now 20% of 100 is 20. If it is added, it becomes 120. Now there is one more change that is required to be done. The breadth is increased by 30%. So the area will increase by 30%. As we said, the effect of change in length and breadth both will be there on the area. Now, this 30% again is calculated on 120, and this is due to change in breadth. Right? Now 30% of 120, 12 threes are 36. So 36 is added, so it becomes 156. This is the final area. Right? I repeat, whatever percentage change happens in length and breadth, the same percentage change will happen in area also, but one after the other. Okay? So initial area 100, final area 156, net change, as you can see, it is straight away 56% increase. And because we could do this, we can also apply successive change method as well, right? So this is our A, that is 20%. This is our B, that is 30%. So the net change is directly calculated as 20 plus, the other method would be, one more method would be 20 plus 30 plus 20 into 30 by 100. 0, 0 cancel. So we have 20 plus 30, 50 plus 2 into 3 is 6, that is 56%. 56% increase. So remember, if the percentage changes in length and breadth are given, the net change in area can be directly calculated with the help of successive change formula, that is A plus B plus AB by 100. Okay, if the net change has to be calculated and the changes in length and breadth are given, you can directly apply this. Okay, it may be decrease also, but doesn't matter, just be careful about the sign of A and B here. Alright, I'll show you physically as well. Let's see. I'll remove this, and here, suppose we increase the length by 20%. Now this is the new rectangle, and this entire thing is the breadth now. This is the breadth now, and this entire thing is the length now. So if I have to increase breadth, what do I do? This is breadth B, this is breadth B. What do I do? Hold this length and push so that it comes here, right? So this thing is 30% of B. So the net change in area, as you can see, this is the change in area, this is also the change in area, and this is the extra change in area. So if you can try and understand, this change was 20%, this change is 30%, and this value is actually that 20 into 30 by 100%. If you don't understand it, this fine, no problem with that. But physically also you can see that. Hence you can directly apply the successive change method. Let's take a couple of more examples. What I'll do is I'll give you a simple table, and from there we'll try to find net change in area. So let's say I put it like this: percentage change in length, percentage change in breadth, and you have to find percentage change in area of a rectangle. Which rectangle? For which the changes in length and breadth are given. So let's take questions one by one. So you have to remember, if the percentage change in length is given A%, percentage change in B breadth is given as B%, the percentage change in area is directly calculated as A plus B plus A into B by 100. No other thought should come, right? So let's say question number 6. Suppose length is increased by 50%, breadth is increased by 30%. What will be the change in area of rectangle? So it is straight away 50 plus 30 plus 50 into 30. This is what you have to find. Divide by 100. So 0 and 0 are cancelled. 5 into 3 is 15. 50 plus 30 is 80 plus 15, that is 95%. So the area increases. 95% increase in area. Now let's take a situation in which things decrease, the values decrease. Suppose we say that the length increases by 40% and the width or the breadth decreases by 30%. Now what will happen? Let's see. Formula remains the same. Just be careful. In place of A we will take plus 40. In place of B we will take minus 30. Okay? Right? Minus sign is decrease. So it is 40 plus minus 30 plus 40 into minus 30 divided by 100. 0 and 0 are cancelled. 40 minus 30 is 10. 4 into 3 is 12 and minus sign. So 10 minus 12, that is minus 2. This means 2% decrease in area. Okay. Be really careful. Let's take one more example. If we have 20% increase in the length and 10% decrease in the width, then net change will be 20 plus minus 10 plus 20 into minus 10 divided by 100. So 0 and 0 are cancelled. 20 minus 10 is 10 minus 2. That is equal to plus 8, right? So this is 8% increase in the area. So you have to always calculate to the last step. Then only you can say anything about the answer. Okay. Let's take one more example. If we say that the length decreases by 30% and breadth also decreases by 20%, then what is the net change in the area? So it will be minus 30 plus minus 20 plus minus 30 into minus 20 divided by 100. 0 and 0 are cancelled. Minus 30 minus 20 is minus 50. Minus 3 into minus 2 is plus 6. Yes, this is where people make mistake. Minus 3 into minus 2 is plus 6. Minus 50 plus 6 is minus 44. So it is 44% decrease in area. Right? Let's take one more. If I have length increases by 20% and breadth decreases by 20%. Right? So length plus, that is increment, and breadth decreases by 20%. What will be the percentage change in area? This will be 20 plus minus 20 plus 20 into minus 20 by 100. See, please understand that this is the important step. You have to be really careful about the sign here. So 20 and minus 20 are cancelled. Here 0, 0, 0, 0 are cancelled. So it becomes simply minus 4. That means 4% decrease in area. Okay. That also tells us if there is any value which increases and decreases by the same percentage, there will always be a decrease which will be square of this number by 100. As you can see, 20 into 20, 400 by 100 is 4. And this will always be a decrease. That we'll discuss later on also in some other topic. Okay. Now let's take some tricky questions.